Now next is differentiation in Z transformation. This one is fifth, right? Yeah. Okay, so if Z transformation of x of n is x of z, then Z transformation of n into x of n is minus z dx of z by dz. Okay, and ROC will remain same. So by the definition of Z transformation, suppose x of z, what is x of z? That is summation of n is equal to minus infinity to plus infinity x of n z to the power minus n, right? Now differentiate both side with respect to z. So this left side we will get dx of z by dz, and right side it will be summation of n is equal to minus infinity to infinity. This is the function of n, so we left this as it is, and this will be minus n z to the power minus n minus 1, right? Now dx of z by dz is equal to summation of n is equal to minus infinity to plus infinity. Can we write this as n into x of n into z to the power minus n, and minus 1 means divided by z. So can I put this here z? Okay, so actually it is minus n minus 1. Okay, instead of minus 1 we can write like this. Okay, and later on with the help of cross multiplication we can move this to the left side, and we have n here, right? Minus n here, so we can move this minus sign to the left side, so this will be minus. Okay, now this look like Z transformation of n into x of n. So this is nothing but Z transformation of n into x of n. Okay, so we can tell that Z transformation of n into x of n is nothing but minus z into dxz by dz. And similarly with n to the power k x of n, we will get Z transformation as minus z to the power k x of z divided by dz to the power k. Okay, now let's take an example. Find the Z transformation of y of n, which is equal to n into a to the power n u of n. Okay, so we all know what is the Z transformation of a to the power n u of n, that is 1 divided by 1 minus a z inverse. Okay, so what will be the Z transformation of y of n? Can we write this equation as n into x of n, where x of n is a to the power n u of n, and this will be x of z. Okay, now this look like the previous form, right? What is the Z transformation of n into x of n? That is minus z dxz by dz. So we can write y of z is equal to minus z dx of z by dz. We know what is x of z, so we need to differentiate this term, and we will get minus z 0 minus a into minus 1 to the power z to the power minus 2 divided by 1 minus a z inverse whole square, right? This is u by v differentiation. Now this can be written as, if you multiply this term you will get a z inverse divided by 1 minus a z inverse whole square. Okay, and what will be the ROC? That will be greater than a. Okay, because ROC doesn't change here. So what is the ROC for this one? Z is greater than a. Okay. Now next is convolution of convolution in time domain. Okay, suppose z transformation of x1 of n is x1 of z and ROC is R1, and z transformation of x2 of n is x2 of z and ROC is R2. Then we need to find z transformation of convolution of both the signal. x1 convolution x2 will give. So we need to find the z transformation of this convolution of both the signals. So this will be x1 of z into x2 of z, and ROC will be R1 integral R2. Okay. Now we need to find z transformation of x1 of n convolution x2 of n, right? Now how to find this z transformation? So this will be equal to summation of n is equal to minus infinity to infinity, and here we put signal x1 of n convolution x2 of n into z to the power minus n. Now summation of n is equal to minus infinity to infinity, we use the convolution formula. This will be m is equal to minus infinity to plus infinity x1 of n into, sorry, this will be m, right, into x2 of n minus m. If you don't remember the convolution formula, see the previous video, you will get to know in signal and system. So this is how we find convolution into z to the power minus n. Okay. Now let n minus m is equal to k. Okay. So m can be written as, or n can be written as k plus m, right? Now put the value here. So this will be n is equal to k plus m, right? So if n is equal to minus infinity, what about k? That will be equal to minus infinity. If n is infinity, what about k? That will be infinity, right? Plus m is equal to minus infinity to plus infinity x1 of m into x2 of n minus m, or we need to write here k, right? Because n minus m is k, into z to the power minus what is n, that is k plus m. Okay. Now this will be k is equal to minus infinity to infinity x2 of k into z to the power minus k. This is we need to separate these two, into m is equal to minus infinity to infinity, and here we write all the m terms, x of m into z of minus m. Okay. Now we can write this equation as x1 of z, and we can write this equation as x2 of z, which is nothing but z transformation of x2, and this will be x1, right, and x1. Okay, I write it here. So this will be the z transformation of, I missed here 1. Okay, this one, this should be x1 of m. Now this is in the form of z transformation of x2 of k, so I can write this as x1 of z, and this can be written as x2 of, sorry, this should be x2, right, x2 of z, and this should be x1 of z. Okay, so z transformation of x1 of n convolution x2 of n is equal to x1 of z into x2 of z. Okay, or if I write z transformation of x1 of n convolution x2 of minus n, then this should be the z transformation of x1 of z into x2 of 1 by z. Okay, so for LTI system, input is x of n and this is response h of n and y of n, output response y of n. So y of n is equal to x of n convolution h of n. Okay, if we find z transformation of y of n, then it should be x of z into h of z, or we can write transfer function h of z is equal to y of z divided by x of z. Okay, at all initial condition is equal to 0. Okay, now in next class we are going to solve a question which is related to this property. Okay, so that will make you more clear about Z transformation. Thank you.